Welcome, Genesis International College carpentry students. Okay, you've tackled the theory, you've read through the manuals, and now? Now it's time to actually bridge all that classroom knowledge with the real world, on-site application. In this explainer, we are completely breaking down Topic 3, constructing and installing bulkheads. We're going to take those detailed specifications and turn them into a rock-solid physical build. Let's get to it. Everything we're covering today is drawn directly from your official Genesis International College Learner Guide for Unit CPCCCA3014. Consider this explainer basically your official foreman-guided study tool. It's specifically designed to walk you through the physical workflow of installing bulkhead components. Think of it like a virtual job site walkthrough right before your practical assessment. Here's our agenda for today. Assessing bulkhead loads, selecting the right fasteners, assembling the frame, positioning and securing, and finally, verifying alignment and compliance. Section 1. Assessing bulkhead loads. Right, so before you ever even pick up a drill or cut a piece to track, you really have to understand the invisible physical forces at play here. Knowing the distinction between these two terms is absolutely vital for your upcoming assessments. Load capacity, well, that deals with the frame itself, like how much weight the brackets, hangers, and the assembled bulkhead can actually hold. Anchor capacity, on the other hand, deals with the building you're attaching it to. It's how much weight that specific screw or masonry anchor can safely carry in that specific material, whether it's timber, steel, or concrete. You've got to have both working together for a safe installation. And honestly, it is incredible how quickly that weight adds up. The golden rule? Never, ever guess a bulkhead's weight. You must calculate the combined load. You see, it's not just about the timber or steel frame. You have to account for factory-applied finishes, edge trims, access panels, the whole shebang. And even more importantly, you have to factor in those integrated services. We're talking heavy downlights, mechanical HVAC ducts, or range hood parts. You've got to have this total weight dialed in before you even start thinking about which brackets to use. Section 2. Selecting the right fasteners. Okay, so now that we actually understand the demand of our total load, we have to pick the exact hardware to support it safely. Listen, a major pitfall for apprentices, and you definitely want to avoid this, is mixing up your fasteners. You have to firmly separate two different fastener types in your mind. Installation fasteners require intense checking because these are your heavy-duty anchors. They carry the entire bulkhead's load straight into the building's main structure. Frame assembly fasteners, though, those are just the lighter screws that simply hold your studs, tracks, and plates together. They are absolutely not interchangeable. To prevent any catastrophic failures out there, you kind of have to act like a detective on site. First up, verify your substrate reality. Do not just rely on what the surface looks like. A nice, smooth rendered wall, it might actually be hiding brick or blockwork underneath, which, as you know, completely changes the anchor you need. Second, respect those corrosion ratings. Fasteners aren't just about pure strength, they're about long-term survival. A standard Class 3 coating is perfectly fine for dry interiors, but if you're framing a bathroom bulkhead, you absolutely must upgrade to a Class 4 coating to handle all that high moisture. And finally, always run a pre-use test. Just drive one trial screw into some scrap material first. That lets you set your drill's clutch perfectly, ensuring a flush seat and preventing you from stripping out the actual frame. Section 3. Assembling the frame. All right, with our hardware meticulously selected, we transition directly from the theory phase into the physical build. Now, whether you're building a straight timber frame, a complex curved feature, or a hung steel frame, you really want to stick to this exact chronological order on site so you don't end up having to pull things down later. Step 1. Build your perimeter by fixing your top and bottom plates or tracks to the approved structure. Step 2. Add your vertical droppers, trimmers, or studs, making absolutely sure you keep them perfectly plumb. And Step 3, stiffen the frame. Install your noggings, blocking, and bracing. Trust me on this one, if your frame isn't totally rigid, the plasterers and painters are going to hate you because every single flaw is going to show up in their final finish. Section 4. Positioning and securing. Let's move to the critical moment where we actually lift, align, and fix our assembled frame to the structural supports. Listen up, because this is a golden rule passed down straight from experienced foremen. As you secure that bulkhead, you must tighten your fixings progressively. If you take your impact driver and just fully crank down the fasteners on one end before you even start on the other, you are guaranteed to pull the entire frame out of alignment. You'll induce this twist that is just incredibly frustrating to fix later. So, snug them up, check your lines, and tighten progressively. Let's be real, real-world substrates are almost never perfectly flat, which means you're definitely going to be using packers. But there are strict rules here. Always place your packers directly behind or right beside the fixing location. That way, the screw pulls the frame firmly against a solid support, rather than just pulling it into empty space. But whatever you do not overpack a single point, because that will instantly distort that frame you just spent all that time carefully building. And hey, if you run into a surface where the gap is just excessively large or terribly uneven, stop right there. Don't just keep stuffing packers into the gap. Call over your supervisor to see if the substrate needs repair or maybe a totally different fixing method.
Your learner guide has this really handy breakdown, perfectly mapping out the exact protocol and alignment checks you need to perform based on what part of the building you're fixing into. For instance, if you're hitting timber ceiling joists, confirm your soffit level on the laser right before you tighten. Using adjustable hangers, set the lowest point first and make sure any curves match your template without leaving weird flat spots. And if you're going steel tracks straight to a concrete slab, just verify your track perfectly follows your chalk line.
Section 5. Verifying alignment and compliance. So, we've framed it, we've secured it, and now we've reached the final stage of our site workflow: rigorous quality control. I actually love this quote from the text. Professional site work leaves absolutely no room for guesswork. You do not just eyeball a bulkhead, say, "Yeah, looks good to me," and call it a day. Every single dimension, level, and clearance has to be proven against the project drawings using your straight edges and lasers. So what does proving it actually look like out there? Well, for straight bulkheads, it means pulling out your straight edge or string line and proving that the front face is plumb and perfectly square to any adjacent walls or, say, kitchen cabinetry. For curved bulkheads, it means taking your template and checking the installed radius at multiple points, just to catch any sections that might have flattened out because a hanger was a bit over-tightened. And if you're using adjustable suspension hardware, you only lock those nuts down after the final level is absolutely 100% confirmed. Running these checks guarantees your work will seamlessly integrate with the finishing trades, and it saves you from some really embarrassing and costly rework down the line. As we wrap up this explainer on topic 3, I want to leave you with this vital safety question to reflect on before you walk into your next practical assessment. Before you drive your very next anchor on site, are you absolutely certain it matches your substrate and your load? If you keep this analytical, step-by-step mindset and stick to the procedures laid out in your Genesis guide, you are going to build flawless, compliant bulkheads every single time. Good luck with your training, and we'll catch you on the next explainer.